All right, so let's say you've developed a QuestionPro survey. You have submitted it. Now you want to analyze it. You'd go to Analytics right here, and then you would download the data. I've already done this. You can choose what option, Excel, comma delimited, you name it, right? We're going to do SPSS, right? I've already done this. I've already opened it up. Let me close this. And so I have the data set, and I had this one question that asked, like, what class are you taking this for, or what have you? And then make believe wording. But these two questions were in a block where I asked them, as I explained in the other video, to rotate them randomly, right? They were given a 0 if the person didn't get that wording, right, but this one. So we need to create a variable in one column that indicates whether they got the first question wording or the second question wording. So easy to do. Let's create a variable. Wording. We have a new variable. We could recode that in the same variable. We'll go to W wording. We're going to change 0 to 1 for question 1 wording. Add that. Click continue. If question 2 is greater than 0. Right? If it's greater than 0, that means that they got the first wording option. Click continue. I'm going to click paste, and this then remembers the code, right, of all the things I just did, put it into syntax, right? So you don't need to actually know coding language of SPSS. It'll produce it for you. So I'm going to run that by highlighting it, pressing the play button there. And I'm going to go look at my data, and it said, all right, it did recode that variable into a 1 if question 2 was greater than 0. I'm going to do the same thing for question 3, right? So we're going to go to transform. Oh no, what's even simpler is copy this syntax language, paste it. If question 3 is greater than 0, then I want wording to change from 0 to 2. Highlight that. Boom. And now, all right, I have a variable that indicates if the respondent received question wording 1 or question wording 2. But now I want their responses, right, to be put into one variable. So this is pretty easy to do. Lots of different ways to do this. I've done it the hard way, the easy way, a lot of different ways. I was playing around with this. You can just add these variables up, right? So we can create compute. We're going to do response. I don't know. We're going to go Q2, let's do capital Q2 plus Q3, and click OK. And we basically get all of these values that are in this, that aren't 0, into this, right? And so now we have the two variables that we would really need to just run a difference of means test, right? To see, hey, is there a difference in responses depending on whether they got question wording 1 or question wording 2. So a difference in means test, right, is simply calculating the means produced by one question versus the other and seeing if there's a statistically significant difference between those two means, right? We could do a crosstab, we could do chi-square, we could do a lot of different things. Just for this purposes, I'm going to do a difference in means test. Given that there's only basically two values, a difference of means test, an independent sample t-test, probably not the most appropriate technique. A chi-square probably would be, so cross-tabulation. There's even a little video in the Elon poll about, reading a crosstab. But a very common technique in analyzing question wording difference is the difference in means test. So we're going to do that. Go to analyze. We're going to go to compare means, independent sample t-test. Again, I don't have a lot of time to tell you the difference between one sample t-test, independent sample t-test, or paired sample t-test. Independent sample t-test is probably the most common. Paired sample is if you are comparing a person's results from time 1 to time t. So they're paired information. Here, this is not paired information, right? The person who got question wording 1 is different person than the person who got question wording 2, right? And we're assuming that they're coming from an independent sample with that randomization. So we're going to click there. We're going to put the test variable, that is the response. And then the wording is the grouping variable. And it will ask you to define those groups. It will sort of like look at the data and say, hey, you probably want group 1 to be representing the value 1 and group 2. Sometimes you'll have 0, 1. So it will sort of anticipate what you want and usually gets it right, but you can change it if you wanted to. And you can do some options depending on confidence intervals that you want, right? And then we can click OK, and we will see the results, right? And what we're basically looking for, right, is the t-value and the significance value here. The significance value here, right? Not for the f-test. So the t-value, usually anything above a 1.96 is going to be statistically significant. And this is saying that depending on a one-sided or two-sided, usually we're looking at a two-sided test, statistical significance test, because we don't know whether it's going, if group 1 or group 2 is going to be larger. If we had a theory that we suspect that group 1 is larger, then maybe we could do a one-sided significance test. Almost always a two-sided significance test is done. And so we see that this, we can look at the actual value if we wanted to by scrolling over here, and we see that the value is much smaller than the traditional 0.05 alpha level that we're looking for. And so if the significance value is smaller than 0.05, and this is much smaller, then we can reject the null hypothesis that these two groups are of equal means, right? They're different enough, right? The two responses, the average of the two responses are large enough, right? The differences are large enough that it's unlikely to be due simply by random chance, right? Based on a confidence interval of 95%, right? Or 95% confidence, right? Now here, based on the significance, we're very confident, right? But we're well beyond the 95% confidence level. And so basically that's one simple way to see, hey, this question wording seems to be causing different responses, a statistically significant response. I was filling out this survey. On purpose, I selected 1 every time I got question wording 1, and I selected value 4, which was the second option, which is why it kept recording number 2. I kept selecting a certain value for each time I was taking the test, so that I knew I was going to produce a statistically significant difference, even though we only have, right, 13 cases, right? With only 13 cases, because I was manufacturing a severe difference between the responses, I got a statistically significant result. If, in the real world setting, we would need 1,000 cases to be able to pick up on more modest response changes due to wording, right? But I forced to do it, right? I forced SPSS to collect data that was significantly different for question 2 than question 3, right? just to produce a statistically significant results, right? So this I wanted to show you because this is just a very common technique of testing whether wording makes a difference, right? And often it doesn't. Often you don't produce a statistically significant. Even in the tests that we did for gay marriage versus same-sex marriage, for most of our tests, we conducted multiple surveys testing it. Most of them produced a statistically significant difference. But in some surveys, they didn't. I'm not exactly sure why. Maybe it could be a lot of different things, right? It could be just random chance. You just get unlucky and you ended up getting maybe perhaps a certain group of people that are not going to be affected by that wording because they were strongly opinionated and they weren't going to be affected whether you said gay or same-sex marriage, right? But for most of the surveys that we did, and we did multiple iterations, we found a statistically significant difference in the direction that we had anticipated, right? And that's why it got published. Even though not every survey produced the result that we did, most of the surveys did, right? So that's a quick little survey to sort of show you how to calculate a difference in means test for a question wording randomization.